March 7, 1944. Kriegsmarine testing facility, Travemünde, Germany. The captured American PT boat sat in dry dock like a trophy of war, its sleek wooden hull gleaming under the cold Baltic sun. Kapitän zur See Friedrich Kemnade stood at the bow, running his hand along the mahogany planking, feeling the smooth craftsmanship that had carried this vessel across thousands of kilometers of hostile ocean. Behind him, a team of naval engineers assembled their testing equipment, preparing to answer the question that had haunted German E-boat commanders for 2 years. Why could they never catch the Americans? Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. The boat before them was PT-59, captured intact during a daring German commando raid on an Allied forward base in the Adriatic Sea on January 23, 1944. The raid itself had been a tactical success, destroying fuel depots and sinking 2 supply vessels. But the real prize had been this patrol torpedo boat, abandoned by its crew during the chaos of the attack, sitting perfectly preserved at its mooring. German forces had recognized its value immediately. Within hours, a salvage team was towing it toward occupied territory. Within days, it was on a transport ship bound for Germany. Within weeks, it sat in Travemünde, waiting to reveal its secrets. Kemnade had commanded E-boats, the German Schnellboote, or fast boats, during the early years of the war. He had led night raids against British coastal convoys in the English Channel, attacking under cover of darkness before vanishing into the North Sea mist. His crews had been among the best in the Kriegsmarine, their tactics honed through countless engagements. Yet increasingly, those engagements had ended in frustration rather than victory. Enemy patrol boats, particularly the American PT boats, operating in the Mediterranean and later in the Channel approaches, consistently outran German pursuit. They appeared from nowhere, launched torpedoes, and disappeared before German forces could close to effective range. The intelligence reports had been troubling. American PT boats were engaging German convoys with impunity, striking fast and withdrawing faster. British motor torpedo boats, or MTBs, showed similar capabilities, though they operated with slightly different tactics. German E-boats, once the terror of the Channel, found themselves increasingly outmatched not by superior weapons or tactics, but by raw speed. The Americans could choose when to fight and when to flee. German commanders could do neither. The psychological impact on German crews had been profound. These were men who had trained for years in small boat tactics, who understood the physics of high-speed naval combat, who could navigate by stars and engage targets in total darkness. They were not lacking in skill or courage, yet they reported feeling helpless as enemy boats simply accelerated away from engagements, maintaining speeds that German vessels could not sustain. It was one thing to be outfought by a superior enemy. It was another to be unable to even reach the enemy to fight. Kemnade's assignment was clinical in its simplicity. Test the captured American boat, measure its actual performance capabilities, compare those capabilities to German E-boat specifications, determine whether the performance gap was real or exaggerated by combat stress and imperfect observation, provide recommendations for improving German small boat performance if improvements were possible. The High Command needed answers, and they needed them based on empirical data rather than combat reports filtered through the chaos of night engagements. The testing program would be comprehensive. Maximum speed trials under various load conditions, acceleration tests to measure time to combat speed, fuel consumption, analysis to determine operational range, handling characteristics in rough seas, engine performance under sustained high-speed operation, hull stress measurements during high-speed turns. Every aspect of the boat's performance would be documented, measured, and compared against known German capabilities. The Kriegsmarine had assembled some of its finest marine engineers for this project, men who had designed and built the E-boats themselves. Walking the deck of PT-59, Kemnade could already see differences that troubled him. The hull design was radically different from German practice. Where E-boats used conventional displacement hulls designed for seaworthiness and range, The American boat featured a planing hull with hard chines and a shallow V-bottom. The design seemed almost fragile, built for speed rather than endurance. The wooden construction, using multiple layers of mahogany planking over oak frames, was lighter than the German practice of using heavier timber or aluminum. Construction. Weight savings appeared to have been pursued aggressively throughout the design. The engines were the real mystery. 3 Packard 4 M2 500 engines, 12-cylinder monsters that occupied most of the boat's internal volume. Each engine displaced over 2,000 cubic centimeters and generated 1,200 horsepower. The total installed power was 3,600 horsepower, driving a hull that weighed only 56 tons fully loaded. The power-to-weight ratio was extraordinary, far exceeding anything in German service. German E-boats, by comparison, typically displaced around 100 tons and mounted 3 Daimler-Benz diesel engines, producing a total of 6,000 horsepower. The absolute power was greater, but the ratio of power to weight favored the American design dramatically. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. The first tests began on March 9, 1944, under clear skies with calm seas in the Baltic. The conditions were ideal for establishing baseline performance measurements. German engineers had spent 2 days familiarizing themselves with the American boat's systems, learning its quirks and operational characteristics. The Packard engines were temperamental compared to German diesels, requiring careful management of cooling systems and fuel mixtures. But once properly warmed and adjusted, they ran with a smoothness that impressed the German mechanics. Kemnade took the helm personally for the initial speed runs. He had commanded small boats for 5 years and understood instinctively how they handled, how they responded to helm and throttle, how they rode through waves and turned at speed. As the 3 Packard engines roared to life, the dock lines were cast off, and PT-59 moved slowly into open water. The engines idled with a deep rumble, all 12 cylinders firing in perfect synchronization. The sound was different from German diesels, higher pitched and more aggressive. Clear of the harbour, Kemnade advanced the throttles steadily. The boat began to accelerate, and within seconds, something remarkable happened. The hull lifted, rising up onto plane as water pressure built under the shallow V-bottom. The bow rose slightly, then settled as the boat achieved hydrodynamic lift. Suddenly, they were no longer pushing through the water but skimming across its surface. The ride transformed from the heavy wallowing motion of a displacement hull to the light, responsive feel of a planing vessel. The speedometer climbed rapidly. 20 knots, 30 knots, 40 knots. At 41 knots, approximately 76 kilometers per hour, Kemnade leveled off to assess the boat's behavior at sustained high speed. The handling was extraordinary. The boat remained stable despite the speed, responding instantly to helm inputs. The planing hull design, which had seemed almost reckless in dry dock, revealed its purpose at speed. By rising onto the surface rather than ploughing through waves, the boat reduced water resistance dramatically. The power that would have been wasted pushing water aside was instead translated directly into forward motion. The German engineers aboard took frantic notes, documenting everything. Engine temperatures remained within acceptable ranges, despite the sustained high-power operation. Fuel consumption was higher than German diesels, but not excessively so given the power output. Hull stresses were surprisingly modest, the flexible wooden construction absorbing wave impacts that would have damaged a more rigid metal hull. The boat's behavior in turns was particularly impressive, heeling sharply but maintaining control even in maneuvers that would have been dangerous in a German E-boat. Kemnade pushed the throttles further. 45 knots. The engines screamed now, all 3 Packards delivering maximum power. The speedometer needle climbed past 50 knots, reaching 52 knots before leveling off, approximately 96 kilometers per hour. The boat was literally flying across the water, its hull barely in contact with the surface, supported by hydrodynamic pressure and forward momentum. At this speed, waves became a blur, the shore a distant line, the wind a physical force that made communication difficult even by shouting. For 10 minutes, Kemnade held the boat at maximum speed, allowing the engineers to document sustained performance. The Packard engines never faltered, maintaining their howling output without overheating or losing power. The hull remained stable, tracking straight despite the tremendous speed. The control surfaces responded precisely to helm inputs. Everything about the boat's design seemed optimized for this single purpose, achieving and maintaining maximum velocity in combat conditions. When Kemnade finally throttled back and allowed the boat to settle off plane, the silence seemed profound despite the idling engines. The German engineers looked at each other with expressions that mixed professional admiration with strategic concern. They had just experienced performance that exceeded their own E-boats by a substantial margin. The gap was not marginal or debatable. It was fundamental and undeniable. The testing continued for 3 weeks. Every aspect of PT-59's performance was examined, measured, and documented. Acceleration tests showed the American boat could reach 40 knots from a standstill in under 60 seconds, nearly twice as fast as German E-boats. Range tests revealed operational radius of approximately 450 nautical kilometers at cruising speed, comparable to German boats despite the higher fuel consumption of gasoline engines. Seaworthiness tests in rough Baltic conditions showed the planing hull could maintain high speed in sea states that would force German boats to reduce speed significantly. The armament was less impressive than the performance. The boat mounted one 40mm Bofors gun, 4 50 caliber machine guns, and 4 21-inch torpedo tubes. German E-boats typically carried heavier gun armament and 2 torpedo tubes, but the American philosophy was different. The PT boats were not designed to fight other surface vessels with guns. They were designed to deliver torpedoes at high speed, then escape before enemy forces could respond effectively. Speed was the weapon. The guns were defensive tools, not primary armament. Kapitän-Lieutenant Werner Tönniges, one of Germany's most experienced E-boat commanders with over 40 combat missions, travelled to Travemünde specifically to evaluate PT-59. Tönniges had commanded S-38 during operations against British coastal convoys and had personally encountered American PT boats during a brief Mediterranean deployment in late 1943. His combat reports had been among those describing frustrating engagements where American boats simply outran German pursuit. Tönniges took PT-59 to sea on March 23, 1944, accompanied by a German E-boat for direct comparison. The trial would replicate combat conditions as closely as possible without actual combat. Both boats would start from standstill, accelerate to maximum speed, conduct attack runs against simulated targets, execute evasive maneuvers, and return to base. The German boat would be S-100, one of the newest and fastest E-boats in service, representing the best German small boat technology available. The results were devastating to German confidence. In every test, PT-59 outperformed S-100 decisively. Acceleration to combat speed favored the American boat by nearly 30 seconds. Maximum sustained speed showed PT-59 maintaining 51 knots, while S-100 achieved 43 knots, an 8-knot advantage that translated to nearly 15 kilometers per hour. In tactical maneuvers simulating torpedo attacks, PT-59 could close to launch range, fire, and open the distance before S-100 could bring weapons to bear effectively. Most tellingly, when both boats attempted to pursue each other in simulated combat, PT-59 could always break contact. No matter what tactics S-100 employed, the American boat's speed advantage allowed it to dictate engagement terms completely. If PT-59 wanted to fight, it could close to effective range. If it wanted to flee, it could open distance until the German boat fell behind. The tactical implications were profound and humiliating. Tönniges filed his report on March 25, 1944. His conclusions were blunt and professional, showing the careful analysis of an experienced combat officer who understood both the technical and psychological dimensions of what he had witnessed. The report would become one of the most significant technical assessments produced by the Kriegsmarine during the war, though its classified status meant few outside senior command. in circles would see it during the conflict. The American PT boat represents a fundamental advance in small combatant design, Turnidges wrote in the opening paragraph. German E-boat technology, developed in the 1930s and refined through the early war years, has been comprehensively surpassed. The performance gap is not incremental but categorical. American boats can engage or disengage at will. German boats cannot force engagement or prevent disengagement. This tactical asymmetry renders conventional E-boat operations increasingly futile against opponents equipped with similar vessels. The report detailed specific areas where German design had been outpaced. Hull design philosophy favored German seaworthiness and range over American speed and acceleration. Engine technology showed American gasoline engines delivering superior power-to-weight ratios compared to German diesels, despite the fire hazard and higher fuel consumption of gasoline. Construction techniques using laminated wood planking produced lighter, stronger hulls than German methods using heavier timber or aluminum. Propeller design and shaft arrangements on American boats reduced drag and improved efficiency at high speed. Turnidges addressed the psychological dimension directly. German crews report feeling helpless when engaging American PT boats, he wrote. This is not defeatism or cowardice. It is accurate tactical assessment by experienced combat veterans. When the enemy can choose whether to engage or withdraw, and friendly forces lack the speed to force either outcome, the psychological advantage belongs entirely to the enemy. Our crews know they are operating inferior equipment. This knowledge affects morale, decision-making, and combat effectiveness more profoundly than any single tactical defeat. The report's recommendations were stark. German E-boat design required complete rethinking from first principles. Incremental improvements to existing designs would not close the performance gap. A new generation of small combatants, optimized for speed rather than seaworthiness, needed development, though such development would take years and strain German industrial capacity, already overburdened by multiple priority programs. In the interim, German E-boat operations should focus on missions where speed disadvantage mattered least, such as minnow-laying or operations in confined waters, where American boats could not exploit their speed advantage fully. The final paragraph of Turnidges's report captured the broader strategic implications. The PT boat represents not merely a faster E-boat, but a different philosophy of naval warfare. American designers have optimized for single-mission performance, accepting limitations in range, seaworthiness, and armament to achieve overwhelming advantage in speed and acceleration. This design philosophy reflects broader American industrial and tactical thinking, specialized weapons optimized for specific missions rather than general-purpose vessels attempting multiple roles. German naval design has traditionally favored versatility and endurance. Against enemies who field specialized weapons in overwhelming numbers, our versatile designs prove inferior in each specialized role. The technical examination of PT-59 continued through April 1944 as German engineers stripped the boat down to its fundamental components. What they discovered went far beyond simple speed advantages. The American design philosophy represented a comprehensive rethinking of small boat warfare that challenged every assumption German naval architects had made during the 1930s when E-boat development began. The hull construction revealed sophisticated understanding of hydrodynamics that German designers had overlooked or dismissed as impractical. PT-59's hull consisted of 2 layers of diagonal mahogany planking over longitudinal mahogany rib bands, all glued and screwed to white oak frames. The double diagonal planking method created a structure that was simultaneously light, strong, and flexible. Under stress, the hull could flex slightly, absorbing wave impacts rather than transmitting them as destructive forces through the structure. German boats, built with heavier single-skin planking or aluminum construction, were more rigid and therefore more prone to structural damage from sustained high-speed operation in rough seas. The Packard engines fascinated and frustrated German engineers in equal measure. Each 4 M2500 engine was a masterpiece of American automotive engineering, adapted for marine use. The supercharged V12 configuration, delivered 1,200 horsepower from an engine that weighed only 630 kilograms. The power-to-weight ratio exceeded anything in German marine engine inventory. More importantly, the engines could sustain maximum power output for extended periods without overheating or failing, something German engineers had believed impossible for gasoline engines operating in confined marine environments. Oberingenieur Klaus Hermann, who had designed propulsion systems for German E-boats since 1936, spent weeks examining the Packard engines with growing professional respect. Hermann had been among those arguing that diesel engines were superior for marine applications due to their fuel efficiency, reliability, and reduced fire risk. The captured PT boat forced him to reconsider assumptions he had held for nearly a decade. "We dismissed gasoline engines as too dangerous for combat vessels," Hermann wrote in his technical assessment dated April 15, 1944. "The fire risk from gasoline is real and significant. American PT boats that suffered combat damage often burned catastrophically, killing entire crews. We were correct about this danger. However, we failed to understand that American designers accepted this risk as worthwhile trade for the performance advantages gasoline engines provide. They calculated that speed reduced the probability of being hit, and that this reduced probability justified accepting increased consequences when hits occurred." The report continued with detailed analysis that revealed the mathematical logic behind American design choices. A German E-boat traveling at 40 knots had a certain probability of being hit by enemy fire during any engagement. An American PT boat traveling at 52 knots reduced its exposure time by approximately 23% simply through higher speed. If the PT boat could also accelerate faster and turn more quickly, the overall reduction in hit probability might exceed 40%. Even accounting for increased casualty rates when gasoline fires occurred, the American boats suffered lower overall casualties because they were hit less frequently. "We optimized for minimizing casualties per hit," Hermann concluded. The Americans optimized for minimizing hits per engagement. Against enemies with limited ability to track and engage high-speed targets, their approach proves superior. "Our diesel-powered E-boats are more survivable when hit, but are hit more frequently. Their gasoline-powered PT boats are less survivable when hit, but are hit less frequently. The net result favors the American design in most combat scenarios we have analyzed." The propulsion system revealed further sophistication. PT-59 used 3 shafts driven through reduction gears that allowed the high RPM engines to drive slower-turning propellers efficiently. The propellers themselves were carefully designed 3-blade units optimized for high-speed operation. The shaft angles and propeller placement minimized interference between the 3 propellers, allowing each to operate in relatively clean water rather than disturbed flow from adjacent propellers. German E-boats used 2-shaft arrangements with larger propellers, a configuration that was efficient at moderate speeds, but less optimal at the extreme speeds American boats achieved. The fuel system incorporated features that addressed the fire hazard Hermann had mentioned. Self-sealing fuel tanks, similar to those used in aircraft, could absorb small arms hits without catastrophic fuel leaks. Carbon dioxide fire suppression systems could flood the engine compartments automatically if fire was detected. Fuel lines used armored coverings in vulnerable areas. None of these features eliminated the gasoline fire risk, but they reduced it to levels American designers considered acceptable given the performance benefits gasoline engines provided. Throughout April, senior Kriegsmarine officers visited Travemünde to examine PT-59 and review the test results. Each visit followed the same pattern. Initial skepticism that American boats could really be as fast as combat reports suggested. Shock during demonstration runs when PT-59 achieved speeds the visitors had believed impossible for a boat of its size. Grim silence during technical briefings that detailed exactly how far behind German design had fallen. Professional discussions about whether anything could be done to close the gap. Vice Admiral Helmuth High, who commanded German naval forces in Norwegian waters where E-boats operated against Allied coastal shipping, arrived on April 20, 1944. Hay had been a destroyer commander during the First World War and understood both the technical and tactical dimensions of small boat warfare. His E-boat flotillas had achieved notable successes against Allied convoys in 1942 and early 1943, but recent operations showed declining effectiveness as Allied escort forces adopted new tactics and equipment. Hay observed PT-59 during high-speed trials on a choppy Baltic afternoon, conditions that would have forced German E-boats to reduce speed significantly. The American boat maintained over 45 knots despite 3-foot seas, its planing, riding over waves rather than ploughing through them. When Hay returned to shore, his first question to the technical team was simple and direct. "Can we build something equivalent?" The answer required an hour-long briefing that covered industrial capacity, material availability, design timelines, and strategic priorities. The short version was technically yes, strategically no. Germany possessed the engineering expertise to design boats matching or exceeding PT boat performance. German shipyards could build such vessels if provided with proper designs and materials. However, actually producing American equivalent boats in meaningful numbers would require resources Germany did not have and could not obtain. The Packard engines were the primary obstacle. Germany had no gasoline marine engine comparable to the 4M2-500. Developing such an engine from scratch would take 18 to 24 months minimum, assuming designers could solve problems. American engineers had already mastered through years of development. Adapting existing German aircraft engines for marine use was theoretically possible, but would require extensive modification and would divert engines from Luftwaffe production at a time when fighter production was critical priority. The construction materials presented equal challenges. PT boats required high-quality mahogany planking, marine-grade plywood, specialized adhesives, and precision fasteners. Germany faced chronic shortages of all these materials. Tropical hardwoods were effectively unavailable due to Allied naval blockade. German-controlled forests provided oak, pine, and fir, suitable for conventional boat construction but less ideal for the lightweight, high-strength structures American designs required. Synthetic adhesives and specialized fasteners were available but were also needed for aircraft production, creating competition for scarce resources. Even if materials and engines could be obtained, the manufacturing infrastructure was lacking. PT boats were built in specialized facilities using techniques adapted from yacht construction and aircraft manufacturing. German shipyards were optimized for building steel-hulled vessels using traditional marine construction methods. Retooling yards for wooden boat construction while simultaneously maintaining production of submarines, surface combatants, and merchant vessels would reduce overall naval production during the transition period. I listened to these explanations with the weary patience of an experienced officer who had heard similar assessments too many times during the war, promising weapons that could not be built in useful quantities because of material shortages, industrial capacity limits, or competing priorities. Technologies that arrived too late or in too few numbers to affect strategic outcomes. Tactical advantages that existed only on paper because the enemy adapted before German countermeasures could be implemented. So we continue operating boats we know are inferior, Hay said, statement rather than question. We continue sending crews into engagements where the enemy holds decisive speed advantage. We continue losing boats and men to opponents who can choose whether to fight or flee while we can do neither. And we tell the crews to maintain morale and fighting spirit despite knowing their equipment is obsolete. Kemnade, who had remained silent during most of the briefing, spoke carefully. We tell them the truth, Admiral. That they are fighting with courage and skill against enemies who possess technological advantages we cannot currently match. That their sacrifice delays enemy operations and forces allocation of enemy resources that might otherwise be employed elsewhere. That naval warfare has always involved accepting unfavorable tactical situations in service of strategic objectives. Hay smiled without humor. Very diplomatic, Capitaine. But these men know when they are being asked to die for strategic objectives that no longer exist. They understand that delaying enemy operations by a few hours, or forcing allocation of a few additional escort vessels, provides no meaningful contribution to a war that is being lost on every front. They continue fighting because they are sailors and because duty requires it. But we should not insult them by pretending their sacrifice changes strategic outcomes. The conversation shifted to operational recommendations. If German E-boats could not match American PT boats in open water speed, how could they be employed effectively? The discussion produced several possibilities, none satisfying. E-boats could focus on mine-laying operations where speed mattered less than stealth and navigation accuracy. They could operate in confined waters like the Baltic approaches or Norwegian fjords, where American boats rarely ventured, and where geographic constraints reduced speed advantages. They could concentrate against Soviet naval forces in the Baltic, opponents who lacked American technological sophistication. Each option represented retreat from the role E-boats had been designed to fulfill: aggressive attack against enemy coastal shipping. The boats that had terrorized British convoys in 1940 through 1942, that had disrupted Allied logistics and tied down substantial defensive forces, then were being reduced to secondary missions because they could no longer compete in the primary role. The psychological impact on crews who understood this reality would be profound. The examination of PT-59 also revealed features that spoke to different operational philosophies beyond pure speed. The American boat had minimal crew accommodations, reflecting its design for short-range coastal operations, rather than extended patrols. The crew of 12 to 14 men had no proper bunks, sleeping on deck or in whatever spaces they could find during multi-day missions. The galley was rudimentary, basically a hot plate for heating, rations. Sanitary facilities were primitive. The entire boat was optimized for combat performance at the expense of crew comfort. German E-boats, by contrast, provided relatively comfortable accommodations for crews who might spend weeks at sea during extended patrols into distant waters. Proper bunks, a functional galley, adequate sanitary facilities, and storage for provisions reflected German design emphasis on endurance and crew welfare during extended operations. These features added weight and reduced performance, but German designers considered them necessary for maintaining crew effectiveness during long missions. The difference reflected broader strategic contexts. American PT boats operated from forward bases with short transit times to patrol areas. Crews could be rotated frequently, returning to base facilities for proper rest and recuperation between missions. German E-boats often operated from distant bases with long transit times, requiring self-sufficiency for extended periods. The different operational contexts justified different design priorities. However, by 1944, the strategic context had shifted. Allied advances in the Mediterranean and preparations for cross-channel invasion meant that German E-boats increasingly operated in coastal defense rather than offensive patrol roles. The need for extended endurance had diminished, while the need for speed and rapid response had increased. German boats designed for the strategic situation of 1940 were less optimal for the tactical requirements of 1944. In early May 1944, Kriegsmarine headquarters convened a senior leadership conference to discuss the PT-59 evaluation and its implications for small boat operations. The conference brought together E-boat flotilla commanders, naval architects, propulsion specialists, tactical doctrine writers, and strategic planners. The stated purpose was determining how to respond to American PT boat capabilities. The unstated purpose was confronting the reality that German naval technology had fallen decisively behind Allied capabilities across multiple domains. Kapitän zur See Rudolf Petersen, who commanded E-boat operations in the English Channel, opened the tactical discussion with brutal honesty. Petersen had led some of the most successful E-boat operations of the war, disrupting Allied shipping during the dark days of 1940 through 1942. His Knight's Cross with oak leaves testified to his operational effectiveness. His assessment carried weight that junior officers' reports could not match. "Gentlemen, we must acknowledge that the E-boat's operational effectiveness has declined to near irrelevance," Petersen began. "In 1940, we terrorized British coastal waters, sinking merchant vessels almost at will. British defences were inadequate, their detection capabilities primitive, their response times glacial. We attacked in darkness, struck fast, and withdrew. before effective response could be organized. Those days are gone and will not return. Peterson detailed the evolution of Allied defensive capabilities. Radar-equipped escort vessels that could track E-boats in complete darkness, high-speed patrol boats, both British MTBs and American PTs, that could pursue and often catch German boats, improved coastal artillery with better fire control. Most critically, the Allied willingness to flood coastal areas with defensive forces in numbers that made every German approach costly and success uncertain. The strategic calculus has inverted, Peterson continued. In 1940, we forced Britain to divert substantial naval resources to coastal defence, resources they desperately needed elsewhere. Today, the Allies have such overwhelming naval superiority that they can afford to station hundreds of patrol boats, dozens of destroyers, and continuous air patrols along threatened coastlines without compromising their ocean-going fleet operations. We have become the force being tied down, forced to maintain E-boat flotillas for coastal defence, while achieving minimal offensive results. The conference participants understood the implications. The Kriegsmarine was fighting a defensive war with offensive weapons, trying to contest Allied naval supremacy with forces designed for raiding and disruption rather than sustained combat. The E-boats, like the U-boats before them, had been rendered strategically irrelevant by Allied technological advancement and overwhelming material superiority. The technical findings from PT-59's examination reached beyond the Kriegsmarine to influence broader German military thinking about technology and warfare. In late May 1944, representatives from the Reich Ministry of Armaments and War Production attended a classified briefing at Travemünde. Albert Speer himself did not attend, but his senior deputy for naval production, Admiral Karl Witzel, came to understand why yet. Another German weapons system had been surpassed by Allied technology. Witzel had overseen German naval construction programs since 1942, navigating the impossible balance between competing demands and inadequate resources. Every weapons system required materials that were needed elsewhere. Every production line competed with others for skilled labor, machine tools, and industrial capacity. The German war economy, stretched beyond sustainable limits, forced constant choices between critical priorities. E-boats competed with U-boats, which competed with destroyers, which competed with minesweepers, all while strategic bombing systematically destroyed the industrial base that produced them. The briefing Witzel received was comprehensive and devastating. The material requirements for building PT boat equivalents were detailed line by line. Mahogany planking, 32 cubic meters per boat, unavailable in German-controlled territory. Marine plywood, 18 square meters per boat, current German production allocated entirely to aircraft construction. Specialized adhesives, 450 kilograms per boat, synthetic production at capacity serving aircraft industry. High-performance gasoline engines, 3 per boat, no German equivalent in production or development. Even if materials could be obtained through some miracle of logistics, the manufacturing challenge remained insurmountable. PT boats required specialized construction techniques that combined yacht-building craftsmanship with aircraft industry precision. German shipyards employed welders and riveters skilled in metal fabrication, not carpenters trained in laminated wood construction. Retraining the workforce would take months. Retooling the facilities would take longer. Building the first prototype would take perhaps 8 months. Achieving series production might require a year or more. Witzel asked the question that haunted German war production across all domains. If we had started developing equivalent boats in 1940 when we first encountered British MTBs, would we have PT boat capabilities today? The answer was probably yes, but that answer provided no comfort. In 1940, German forces were winning on every front. The Kriegsmarine dominated European coastal waters. E-boats were devastatingly effective against British shipping. There had been no compelling reason to invest resources in developing faster boats when existing boats exceeded requirements. The decision to continue refining E-boat designs rather than pursuing revolutionary alternatives had been entirely rational, given information available in 1940. By the time Allied technological superiority became apparent in 1942 and 1943, Germany lacked the resources to respond effectively. The window for developing competitive small boats had closed. The industrial capacity and materials that might have produced German PT boat equivalents were allocated to more critical needs: fighters to contest Allied bombing, tanks to stem Soviet advances, U-boats to attack Atlantic convoys, synthetic fuel to replace petroleum Germany no longer controlled. This pattern repeated across German weapons development. Technologies that might have been decisive if deployed in 1940 or 1941 arrived in 1944 or 1945 when they could no longer affect strategic outcomes. Jet fighters, advanced submarines, guided missiles, infrared detection systems all demonstrated German engineering excellence applied too late to matter. The Me-262 jet fighter entered service in July 1944, but numbered only a few hundred aircraft against thousands of Allied conventional fighters. The Type 21 Electroboat began operations in April 1945 when Germany had weeks remaining before surrender. The PT-59 examination became a case study in this phenomenon. By the time German engineers understood what American designers had achieved, the war had progressed beyond the point where small boats could influence outcomes. Even perfect German PT boat equivalents appearing in mid-1944 would face overwhelming Allied superiority in numbers, operational experience, and supporting infrastructure. The Allies would field hundreds of PT boats supported by extensive logistics networks, repair facilities, and trained crews. Germany might produce dozens of boats operating from bases under constant air attack with inadequate supplies and increasingly inexperienced crews. Throughout June and July 1944, German E-boat flotillas continued operations with full knowledge that their equipment was obsolete and their missions increasingly futile. The courage this required deserves recognition. These men understood probability, knew the statistics, recognized that speed disadvantage made survival unlikely over multiple missions. They operated anyway, because duty demanded it, and because abandoning the struggle would dishonor the comrades who had already died. Oberleutnant zur See Götz von Mirbach commanded S-136 during operations against Allied invasion forces following D-Day in June 1944. His war diary, preserved in naval archives and declassified decades later, provides insight into the psychology of fighting with inferior equipment. The entries are clinical, almost detached, documenting each engagement with precision while revealing undercurrents of frustration and resignation. June 8, 1944, von Mirbach wrote, departed Cherbourg 2200 hours with orders to attack Allied shipping in the Seine Bay. Encountered enemy patrol vessels at 0130 hours. Range approximately 4,000 meters. Increased speed to attack position. Enemy vessels accelerated and opened range. We achieved 42 knots in pursuit. Enemy maintained 48 to 50 knots, opening distance steadily. Pursuit continued for 20 minutes before we broke contact due to fuel concerns and proximity to enemy air bases. No engagement possible. Returned to Port 400 hours, having accomplished nothing except demonstrating our inability to force engagement against enemies who choose to avoid battle. The entry for June 10th recorded similar frustration. Attempted to intercept Allied destroyer escort reported by reconnaissance 8 kilometers off Point du Hoc. Located target at 2340 hours. Began approach from stern quarter, hoping to close to torpedo range before detection. Target acquired us at approximately 6,000 meters, probably by radar. Target increased speed and turned toward us, forcing us to break off approach. When we attempted to withdraw, target pursued at speed, we could not match. Only by splitting our formation and using smokescreen did we escape. Lost contact at 0115 hours. S-148 reported minor damage from destroyer gunfire. 1 crew member wounded. No enemy casualties inflicted. Von Mirbach's final entry was dated June 23, 1944. Orders received for tonight's operation. Attack Allied landing ships near Utah Beach. Intelligence indicates heavy patrol boat presence, both British MTBs and American PTs. Recommendation: Mission should be reconsidered given enemy speed advantage and radar coverage. Recommendation denied. Will execute orders as directed. Expect significant casualties. If this diary is recovered, please inform my family I died doing my duty even when that duty was futile. S-136 was sunk on June 24, 1944, by combined attack from American PT boats and British MTBs. There were no survivors from the crew of 23. Von Mirbach was 26 years old, a Naval Academy graduate who had joined the Kriegsmarine in 1937, believing he would serve in a navy that dominated European waters. Instead, he died commanding obsolete boats in hopeless missions against technologically superior enemies. His story was not unique. Throughout summer 1944, German E-boat losses mounted as the boats were thrown into desperate attempts to disrupt Allied operations in the English Channel. The speed disadvantage that PT-59's examination had confirmed mathematically played out in combat reports filed by the few boats that survived each engagement. The pattern was consistent. German boats attempted to attack Allied shipping, were detected by radar before achieving firing position, were intercepted by faster Allied patrol boats, and either withdrew having accomplished nothing or were destroyed attempting to escape. By August 1944, E-boat operations in the Channel had been effectively suspended except for mine-laying missions. The boats that had terrorized British convoys in 1940 conducted defensive patrols in the Baltic, protected German coastal shipping from Soviet submarines, and waited for the inevitable Allied advance that would capture their bases and end their operational effectiveness permanently. The strategic impact of Allied PT boat superiority extended beyond the small boat confrontations themselves. German coastal defense planning had to account for the possibility that Allied PT boats could penetrate defensive zones, attack shipping in supposedly secure waters, and withdraw before German forces could respond. This required maintaining substantial defensive forces in coastal areas that might have been deployed elsewhere. It forced dispersal of German naval assets to protect against threats that rarely materialized but could not be ignored. More significantly, the PT-59 examination reinforced German leadership's growing understanding that Allied technological superiority was comprehensive and decisive. It was not limited to radar or to small boats or to any single domain. Across every category of military, technology, from aircraft to tanks to naval vessels to communications equipment, Allied forces deployed weapons that matched or exceeded German capabilities. The mythology of German technical superiority that had sustained early war success had been revealed as delusion. This psychological impact may have been PT-59's most significant contribution to Allied victory. Every captured weapon system, every tactical defeat, every examination that revealed German inferiority reinforced the certainty that the war was lost. German scientists and engineers who believed in 1940 that they served the world's most advanced military found themselves in 1944 studying enemy equipment that exceeded their understanding. German commanders who had dominated opponents in 1940 and 1941 found themselves in 1944 commanding forces that could not compete technologically. The examination results were briefed to Hitler in July 1944 as part of a broader assessment of naval capabilities. The meeting occurred at the Wolfschanze headquarters in East Prussia, attended by Großadmiral Karl Dönitz, who had replaced Erich Raeder as Commander-in-Chief of the Kriegsmarine in January 1943. Dönitz's presentation covered the entire spectrum of naval operations, but the section on small boat effectiveness proved particularly uncomfortable. Hitler's response to the PT-59 findings revealed the disconnect between political leadership and military reality that characterized German strategic thinking by mid-1944. Rather than accepting the assessment that German E-boats were technologically inferior, Hitler demanded explanations for why German engineering had failed to match American capabilities. He questioned whether the test results were accurate, suggesting that combat conditions might show different outcomes than controlled trials. He proposed that German designers develop revolutionary new boats that would surpass American technology. Dönitz, who had commanded U-boats through the catastrophic defeats of 1943, and understood exactly what Allied technological superiority meant, attempted to explain that developing superior boats required time and resources Germany no longer possessed. The war would be decided by battles already underway, not by weapons that might be ready in 1945 or 1946. Hitler dismissed these concerns, insisting that willpower and determination could overcome material disadvantages. The meeting ended with orders to accelerate development of advanced E-boat designs, incorporating lessons from PT-59. These orders joined dozens of similar directives, demanding miracle weapons that would reverse German fortunes. The engineers and designers who received these orders understood they were being asked to perform impossible tasks with non-existent resources on timelines that defied physical reality. They worked anyway, because refusal meant accusations of defeatism or worse, producing paper designs for boats that would never be built while the war continued its inevitable course toward German defeat. PT-59 itself remained at Travemünde through autumn 1944, used for training and additional technical studies. As Soviet forces advanced toward East Prussia and the Baltic region came under direct threat, orders were issued in January 1945 to scuttle the boat rather than allow its recapture. On January 27, 1945, German engineers opened seacocks and sank PT 59 inches shallow water near Travemünde. The boat that had travelled from an Adriatic raid through German technical examination to final destruction in Baltic waters had served its purpose. It had shown German naval engineers exactly what they faced and exactly how far behind they had fallen. The lessons from PT-59 extended into post-war naval development, American PT boat design philosophy, emphasizing speed and specialized performance over versatility and endurance, influenced fast attack craft development worldwide. The Soviet Union, which captured extensive German naval documentation, including the PT-59 examination reports, incorporated the lessons into their post-war fast attack craft programs. NATO navies developed high-speed patrol boats that traced lineage directly to wartime PT boat concepts, optimizing for speed and weapons delivery rather than traditional naval versatility. German naval architects who survived the war and resumed careers in post-war naval construction carried forward understanding gained from examining Allied technology. The Federal German Navy established after 1955 operated fast attack craft that showed clear influence from both German E-boat experience and lessons learned from studying American PT boats. The boats combined German emphasis on seaworthiness and endurance with American-inspired speed and agility, creating vessels that balanced competing design priorities more effectively than either wartime predecessor. The human cost of technological inferiority manifested in the statistics compiled after war's end. German E-boat forces lost approximately 1,000 men killed during the war, from total personnel strength that numbered several thousand across all flotillas throughout the conflict. The casualty rate approached 30%, extraordinarily high for naval forces that conducted primarily hit-and-run operations rather than sustained combat. The speed disadvantage that PT-59's examination quantified translated directly into casualties, as German boats unable to escape faster Allied pursuers were destroyed with their crews. These men died knowing their equipment was inferior, understanding that each mission faced enemies who held decisive advantages, recognizing that their sacrifice would not alter strategic outcomes. They continued fighting because naval tradition demanded it, because comrades depended on them, because abandoning the struggle while the war continued was unthinkable. Their courage deserves acknowledgement, even as their cause does not deserve victory. They were not fighting for a just purpose, but they fought with honor against overwhelming odds, using inadequate equipment in futile missions. The story of PT-59's examination represents a broader truth about technological warfare. Equipment superiority matters profoundly in military conflict. Superior weapons allow forces to choose when and how to engage, to minimize their own casualties while maximizing enemy losses, to achieve objectives while denying opponents the ability to respond effectively. Courage, skill, and determination cannot fully compensate for technological inferiority when that inferiority is substantial and sustained. Germany entered World War II believing in technological superiority that proved illusory. By 1944, German forces fought with equipment that was outdated, outnumbered, and outmatched across nearly every domain. The examination of a single captured PT boat in March 1944 revealed this reality with mathematical precision. German naval engineers measured the performance gap, calculated its tactical implications, and reported conclusions that confirmed what combat veterans already knew. They were fighting a war they could not win, with weapons that could not compete against enemies who possessed industrial capacity and technological sophistication that Germany could not match. The captured PT boat sits today in shallow Baltic water where it was scuttled 80 years ago, its wooden hull long since rotted away, its Packard engines corroded to rust. But the lessons it taught remain relevant to military professionals, studying how technological advantages translate into battlefield success. Speed was not merely desirable but decisive. Design optimization for specific missions proved superior to versatile general-purpose weapons. Industrial capacity to produce advanced weapons in quantity mattered more than engineering elegance in prototype development. These lessons shaped Cold War military development and continue influencing modern weapons design. The examination of PT-59 stands as testament to how a single captured weapon system can reveal strategic truths that alter understanding of warfare itself. German engineers who studied that boat understood they were not merely examining enemy technology, but confronting the physical evidence of their own defeat. The copper magnetron in the Rotterdam radar set had explained U-boat losses. The mahogany hull in the captured PT boat explained E-boat failures. Both revealed the same truth. Germany was fighting enemies who possessed not merely more weapons but better weapons, deployed in overwhelming numbers by industrial powers that Germany could not match. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.